Hello everyone. Today I would like to talk to you about characterizing uterine fibroid tissue using the IVIM model and in particular on the need of T2 correction. So what are uterine fibroids? Uterine fibroids are benign tumors which are very common in women. They can cause many symptoms such as heavy menstrual bleeding, pelvic pressure or discomfort, sudden or severe pain, and even reproductive health problem. There are several therapy approaches for fibroid, such as hysterectomy, myomectomy, uterine artery embolization, and high-intensity focused ultrasound treatment. MR-guided HIFU is a therapy method using real-time MR imaging to monitor the elevation of temperature at the HIFU focus during ablation. It's more safe and requires shorter recovery time comparing with the other therapy approaches. However, it is not efficient for all fibroids. Funaki classified fibroids into three categories according to their relative signal intensity in a T2-weighted image compared to the surrounding myometrium and skeletal muscle. As it is shown in the table, only type 1 and type 2 fibroids, which have comparable signal intensity with skeletal muscle or lower signal intensity than the myometrium, can be efficiently treated by HIFU therapy. However, fibroids which have higher signal intensity than myometrium and skeletal muscle, the so-called type 3 fibroid, do not respond well to HIFU therapy. Why do type 3 fibroids have poor treatment response for HIFU therapy? The treatment response may be determined by underlying tissue properties such as density, moisture content, and collagen content. Moreover, type 3 fibroids are assumed to have higher blood perfusion. Tissue perfusion can be measured by two methods. One is conventional dynamic contrast enhanced imaging, and the other is diffusion-weighted imaging with IVIM model. However, prior studies show that these two approaches give different results. DCE MRI-based characterization of fibroids suggests that type 3 fibroids are highly vascular and well perfused, while IVIM model shows that the perfusion is not different among fibroid types. We hypothesize that IVIM model may be able to distinguish fibroid types if the intrinsic T2 difference between the fibroid tissue and blood is taken into account. Intravoxel incoherent motion model was introduced in 1988. In this model, the signal intensity in DWI contain both diffusion and perfusion effect, as it is shown in the function. It yields information about tissue microstructure in terms of diffusion coefficient D, as well as tissue perfusion via parameters perfusion coefficient D star and blood volume fraction F. However, as the DWI are collected by spin-cycle sequence, the T2 value of tissue will also contribute to the signal intensity. In the IVIM model, both diffusion component and perfusion component are assumed to have the same T2 value. Studies have shown that blood has much longer T2 than the fibroid tissue. The purpose of this work is to investigate if the effect of T2 difference between fibroid tissue and blood for the IVIM model. We modeled the effect of this T2 variation numerically and tested the model from the data acquired in vivo. In IVIM model, the signal decay is contributed by the diffusion of the tissue and diffusion and perfusion of the blood, As it is shown in the function, we introduce T2 of the tissue to the first term and the T2 of blood to the second term. The last function is the T2 corrected IVIM model. From this function, we can expect that only the perfusion volume fraction would be affected by T2 correction. In the following slides, D star, and F are used to present the parameters generated by the IVIM model without T2 correction. D star C and FC are used to present the parameters generated by the model with T2 correction. We first did a simulation to find out the predicted error in blood volume fraction estimation introduced by not accounting for T2 difference between fibroids and blood. As it is shown in the plot, without T2 correction, the estimation of blood volume fraction can be fraught with significant errors, particularly for type 1 fibroids. The relative error in the estimation of F diminishes when the fibroid's T2 approaches the blood T2, but this error remains substantial. To prove our hypothesis, we totally recruited 14 patients with 41 fibroids in this study. For all patients, we collected both T2 map and DWI with the same image location and resolution at 1.5 T by Philips MRI scanner. Here are all the sequence parameters. To classify the fibroids, T2 of skeletal muscle were also measured in all patients. Its mean value was 43.2 milliseconds with standard deviation 5.5 milliseconds. So we took 49 milliseconds, which is mean value plus 1 standard deviation as a reference T2 value to separate type 1 and type 2 fibroids. And we used 130 milliseconds, which was a reported T2 value of malmetrium, as a reference value to separate type 2 and type 3 fibroids. Finally, we have 12 type 1 fibroids and 29 type 2 fibroids in this study. No type 3 fibroids were found. Here are the DWI with 10 different B-value and blood volume fraction map of one type 2 fibroids with T2 value of 69 milliseconds. It is clear that FC is substantially lower than F. For all fibroids, F error was calculated and plotted in the simulation result figure. We found that the observed errors are in line with the theoretical predictions. There was no statistically significant difference in the IVIM model parameters, diffusion, perfusion, or blood volume fraction between type 1 and type 2 fibroids without T2 correction. As predicted by the theory, T2 correction does not affect diffusion coefficient or perfusion coefficient, but it introduces a statistically significant difference in perfusion volume ratio. FC is significantly lower than F for both type 1 and type 2 fibroids. Type 2 fibroids have significantly higher FC than type 1 fibroids, which is in agreement with the reported DCE results. In addition to IVIM model, we also measured ADC with different combination of B values using DWI. We found that ADC values measured by the first B value equal to 0 and the second B value up to 800 millimeter square per second are slightly higher in type 2 fibroids, and the value difference between type 1 and type 2 fibroids decreases with the increasing of the second B value. As we know that the perfusion contribution in ADC decreases with the increase of the second B value, this decreasing suggests that perfusion may be a more discriminating tissue property than diffusion between type 1 and type 2 fibroids. We also found there is a relationship between T2 of the fibroids and the diffusion and the perfusion. We created a histogram of T2 value from 41 fibroids, with each being spanning a 10 millisecond interval. The mean and standard deviation of D, DC, F, and FC values of the pixels within each bin was also calculated. In both figures, the green curves shows the uncorrected IVIM model's variation with T2 value of fibroids, and the black curves shows the variation of the corrected parameters. We found that D, DC, and FC all exponentially increase with the T2 of fibroids. If we assume T2 of blood is 290 milliseconds at 1.5 t, DC could be well fitted with an exponential function, and it is asymptotically approaches 1.79 multiplied with 10 to negative third millimeter square per second as the T2 of the tissue of interest approaches the T2 value of blood. It is worth noting that this number is less than the free water diffusion at body temperature, presumably because of the protein in the cellular content of blood. We note in passing that D value measured within small region of blood vessel were close to this asymptotic limit. FC could also be fitted with exponential function, and FC asymptotically approaches a blood volume fraction value of 21.74%. As FC shows the tissue perfusion, it can serve as a perfusion-related parameter that provides information equivalent to non-perfused volume without using of contrast for HIFU treatment results elevation. Here is an example of a 12-month following-up study for a HIFU-treated fibroid. The left image is contrast enhanced image. In this image, the whole fibroid shows non-perfused, and the bright region surrounding the non-perfused volume is the enhancing myometrium. The middle color map is the F map, and the right color map is the FC map. We can see that compared with the F map, the non-perfused volume has a much more clear boundary in FC map. In conclusion, in this study, we proved that T2 correction is essential in using IVIM-based models for uterine fibroid tissue characterization, and T2 corrected blood volume fraction may serve as a non-contrast quantitative biomarker that provides information about local fibroid perfusion.